Hi, I'm Louise Pennington. I'm the Professional Development Leader for Maths and Numicon at Oxford University Press in the UK. Thank you for joining my session today. I'm going to focus on 5 tips to inspire a love of maths in children. So here is the overview of my 5 tips. The first one is approaches. I want to spend a little bit of time focusing on some key approaches that allow us to instill a sense of enjoyment in mathematics, to engage children and to get the best out of them. We're also going to spend a little bit of time looking at manipulatives, which is my favourite thing. We're going to also focus on assessment for learning, something that teachers do really well in the classroom every day. Thinking about reasoning and problem solving and how this supports children in their engagement in mathematics. And then finally, contextualising the learning. We're trying to inspire a love of maths here, so to put maths in context is really important. So number 1, approaches. For me, there are 4 key things to share with you here. The concrete, pictorial and abstract approach, also known as the CPA approach. The Numicon approach, something really close to my heart. Some multisensory approaches that support particularly understanding of number, but early concepts. And finally, the connected model. So first of all, some of you may well know Bruno. He is very well known. So this slide represents a visual summary of Bruno's forms of representation, which is the basis of the CPA approach. And this is what Numicon has at its core. The enactive phase involves real experiences and concrete resources. So our manipulatives come in here, and it forms the basis of learning about any new idea or concept. Concrete experiences are necessary whenever a new idea is encountered. Next, we have the iconic phase or pictorial phase. This is when learning moves into representations of real things, where pictures and diagrams and jottings become important to support understanding. The abstract phase of learning is where learning happens mainly through talking, reading and the use of symbols, so words and numbers, for example, in mathematics. Children meet really abstract representations very early and often are encouraged to move to the abstract representations a little bit too quickly. It's important to recognise here that these phases are not linear necessarily, that we can move fluidly between the 3 different phases and the forms of representations that Bruno detailed. So I am a visual learner, and so for me, thinking about the CPA approach, I like to see things summarised. So I'm just going to quickly run through. So the first one is concrete. So as we have already said, the CPA approach is not a linear journey. There will be times when less manipulatives are needed, when children have internalised the process or understand a concept fully, and they can use their knowledge flexibly. Pictorial phase, as we have said, is where we start to use jottings and pictures, and it's a more 2-dimensional phase of learning. Very, very important and often can be skipped a little bit. So children can miss this phase or not spend enough time here, so they don't start to jot down their thought processes in a less formal way. And then the abstract phase, so working in symbols and words, it's our ultimate aim, and we get there by lots of experiences in the concrete and pictorial phase. So when these things have been used by teachers in their teaching and children have experienced their learning in this way, we get a much more connected way of learning. The Numicon approach is next. This one is something really close to my heart, as I said before. So this is Numicon. So Numicon is a proven approach for teaching and learning mathematics that emphasises 3 key aspects of doing maths: communicating mathematically, exploring relationships and generalising. And as the diagram shows, again, it's a cyclical process. So Numicon uses a range of apparatus and imagery throughout the activities. Physical resources give pupils time to share images with which they can communicate about abstract mathematical ideas, making patterns easier to see and notice and talk about, and in sharing their developing ideas about mathematics and exploring the relationships within maths, pupils can make connections much more readily. And see patterns are spotted in one situation might be noticed and applied somewhere else. So exploring relationships, as we can see, is really, really important to the Numicon approach. Communicating mathematically isn't just about talk. It is definitely about being active, engaging in learning, illustrating our thoughts and our thinking, and also talking and listening as well. As pupils learn to communicate mathematically, they learn to think mathematically too. This involves them being really active in their learning. So pupils are physically active when manipulating resources. They also actively engage in the learning through doing maths themselves. Illustrating, doing maths involves illustrating because maths is about relationships. And it's impossible to explore these relationships without some kind of spatial images being used. Even when thinking about two numbers, one of them comes from the other. So a number line is brought to mind when we think about that. These relationships all involve spatial imagery, and the Numicon approach involves illustrating in every activity. This is how relationships are explored and communicated in a range of different contexts. And talking, doing maths, is really important that we can communicate at the same time. So talking is essential in all Numicon activities and all maths activities actually. Talking means taking part in the dialogue. So between teacher and pupil, between pupils and pupils, and everyone is actively involved, and that enables them to be thinking and doing at the same time. So again, it does inspire that love of maths when children are thoroughly involved in what they're doing. And then generalizing, really, really important, because if you are learning something, this is about, if I know this, then what else do I know? If I know this concept, what else does that link to? So this is kind of mapping and linking of ideas together. And altogether, those three things make the Numicon approach. Multisensory. So you can probably guess that Brunos theories and the CPA approach and also the Numicon approach all have multisensory elements at their core. So multisensory approaches are ones that integrate sensory activities. So children see, hear and touch as they are learning. And so we use those channels by encouraging children to look and to listen and to talk to each other and to you as the teacher, and also touching, so manipulatives, moving things around on the table. And in some cases, not often in maths, obviously, but in some cases, using our sense of smell and even our sense of taste can support those multisensory approaches. Particularly helpful when we're looking at learning about number and the value, size and quantity of numbers, because to kind of touch and feel is really important. And this is what Numicon is so great for. So the fact that we have pick up and touch that feels real. Multisensory techniques stimulate the brain. There's lots of research around that, and they help children therefore to understand and remember. So we're engaging and we're fostering that love of mathematics by having low stakes, low stress environments. Children are generally more attentive when multisensory techniques are being used, and that's really important. And as we've said, that multisensory learning aids remembering, and it also aids that transfer from the here and now remembering, so understanding and keeping something in your mind for a few seconds, so our working memory. It also supports children to transfer that for long-term storage or information, and so that they can recall it much more easily tomorrow or next week or the week after, or even at any point in the future. And so if we understand something really well, we make connections stronger within our learning, and then we can commit it to long-term memory, also find a way back to where it is. So we're storing like concepts together. Again, as I said, I like visuals. So for me, this is really important. So if you imagine that the learning is the funnel here, so if we have experience of the learning and we're doing that for ourselves, it supports us in understanding much more readily, and also therefore to remember. Those three things are linked. And if we have that experience within a maths lesson, we're engaged and we're learning and talking and being active, then we are much more likely to remember and keep our learning in the long-term retention. The connected model. So this is something that I have written an article about, and hopefully after this session you'll be sent a link for this, and also a summary around the CPA approach if you want to do a little bit more reading. So the connected model, this picture here shows that pictures are mathematical images. They're the structure. So that's very much like the pictorial phase of learning. So we have the concrete experiences at the bottom. That's the C for CPA. The pictures, pictorial phase at the side. So the P, and the symbols is the A, the abstract. And what Haylock and Coburn did in their model, their connected model, was they made a real clear link between the CPA approach, but also the use of language. So the language of mathematics, the complex language that we use, the language that is specific to maths, and also the language that we might use that means something different in mathematics. So they're very, very clear that we should teach the language associated with maths, that we should model the correct use of it, and that when we're doing that and the children are active and taking part using manipulatives, then we have a much more connected model in terms of an approach to teaching. So concrete, pictorial and abstract phase, but making very explicit links to the right use of language for the children. Another visual. This is really important for me. Active engagement in mathematics leads us to develop automaticity. Now, if you haven't heard of that term, I'm going to use the picture on the screen. So have you, if you drive a car, have you ever driven from your home to somewhere familiar? So maybe a relative's house or to your place of work, to school. And have you ever got there and suddenly thought, I'm not quite sure how I got here? So, but you've done it safely. And that's because your process, the route is familiar to you and the driving process is familiar. So it happens automatically. Your brain doesn't need to use all its power to do that one act. And so what happens is you can do parallel processing. So you can do something else at the same time. So on this journey, when you've got to your familiar place and you've realized you weren't aware of the whole journey, you could have been listening to the radio. You might have been talking to a passenger in the car. You may have been thinking about something, and your brain can do that because the process of driving is automatic. And what we want children to be able to do is develop fluency. So things become practiced and more fluent. And then over time, we have automaticity so that the processes happen in the background. It's a little bit like having tabs open on your computer, isn't it? That if you have just one or two tabs open, your computer runs more quickly. If you have a lot of tabs open, then your processing is slowed down. So this is about keeping our tabs down, so we have much more brain power left to actually do the maths. That's what this slide is around. So my key thing here is that maths is not a spectator sport. It's meant to involve children, to excite them, to engage them, and then foster that love of the subject. The second thing is manipulatives. And as I said before, it's one of my key things that I talk about and work with teachers on, is the use of manipulatives. And in Western culture, there's been a growing use of manipulatives over a number of decades. And what I'm not talking about here is maths equipment. I don't mean rulers and calculators or an abacus. I'm talking about concrete resources that children can pick up and touch and move that helps them understand the maths that they are looking at. Manipulatives definitely go hand in hand with the CPA approach, and they help children to do the maths, to visualize the maths and to understand it much more deeply. So I'm talking about things like Numicon shapes, as I just waved at you. So Numicon shapes. I've got a couple here in my hand. Things like Dean's, so base 10 equipment, which you may have in school. Things like Cuisenaire rods, so the wooden or plastic rods that represent relationships and numbers. They might be cubes that link together. It could be coloured counters, dice, bead strings, place value cards or place value counters, playing cards, and many more things. And over time, and through use of manipulatives in specific tasks, children should need them less and less because they have remembered and internalized what they've done with manipulatives, and they can start to imagine in their head. And so they develop that internal imagery and action, which is what we call, you know, mental maths, working just purely in our mind. So here is some manipulatives. These are some from a Numicon equipment box. So I'm just going to quickly show you the kinds of things that I'm talking about. So I'm talking about things like Numicon shapes, which represent numbers 1 to 10, and other things later on in maths. Things like feely bags, where children can use their sense of touch. So we could put something in the bag and they can't see it, but they have to describe it or give some properties of the item they're touching. So really important for sensory experiences. A variety of number lines. So you can see here at least 3 or 4 different number lines in this particular kit. Very important to support children in understanding about the size and magnitude of numbers, their position on the number line, how calculation works in terms of, you know, moving up or down a number line. The Numicon baseboard, one of my favourite bits of manipulative. So this is a baseboard that has 100 knobbly bits on, sticky up bits, and that can be used for a real variety of activities, including things like pattern and symmetry, looking at parts of 100, so fractions, decimals, percentages later. They also have in some of the Numicon kits some overlays, and this one here that you can see is a picture overlay. It's for young children to become more familiar with Numicon by manipulating and matching shapes to pictures. There are also a set of number overlays where they work on bonds of numbers within and to 10. A really great resource. They click onto the baseboard in Numicon. They also fit in the Numicon shapes, but we're talking here about individual items that can be moved and counted and grouped and used for pattern. Numicon spinners, they are really great for generating random numbers or playing games where we want the next question to be different from the one before. So there's lots of different spinner covers that go on there, some numbers, colours. We can do things like add 10 or multiply or divide. So we can see they can be used for a variety of activities. Numeral cards. So this looks like a pack of cards. It just has cards that have numbers on. So 0 through to 100. So for use in activities, for ordering and sorting, for labelling. Really important to have the ability to label numbers as we're working with them. And finally, dice. So you will see these dice are a little bit different. I'm a big user of dice with children. These dice have got numbers on, numerals. They have also got the Numicon patterns. So 6 has a number 6 on, and also the pattern of 6 for Numicon, which is this. So manipulatives are, you can probably tell by my voice that I am a keen advocate of the use of manipulatives in maths classrooms. However, they need to be used carefully. So children need time to investigate, to get to know the manipulatives, to find out what kinds of things they can be good for, how they fit together. And then and also to kind of play with them, so they've got that out of their system when they need to focus and use them for activities. You will see in the picture in the top right hand of the screen, there are 3 children using a pan balance. That's because the Numicon shapes are actually weighted. So a 7 weighs the same as a 4. Let me get a 4. and a 3. So a 7 in a pan balance would weigh the same as a 4 and a 3. And whilst children need to get to know the manipulatives they have available to them in school, so actually do their teachers. So here are some pictures of teachers exploring activities that they are going to give their class, so they can find out what the children might see or what they might talk about or what they'll find out when they start to use manipulatives. So here we have things like strips of paper. So this activity, I asked these teachers to make a strip of paper that was 1,000 centimeters long, and they only had pieces of paper and one small ruler. So they had to find a way to accurately measure that out. A really interesting task to do. They have made 3-dimensional shapes with straws and plasticine. They've also laid out patterns and looked at how the Numicon, this is Numicon materials on the right hand side, how they fit together. And you can also see that these images show engagement and enjoyment from the adults, so from teachers as well. That's really important. So if we enjoy mathematics and we are engaged in mathematics, then that means a lot to the children in terms of what they feel about the subject. So just to recap, familiarity is necessary both for children and for the adults. And for us as teachers, we need to be really familiar with the concrete resources and the manipulatives available in school to use. So what have you got? Is it natural objects? Have you got stones or pebbles or counters? Can you use fruit? Have you got small figures that your children might play with? Have you got Numicon? Do you have counters in school? So it's probably a good idea if you don't have a lot of manipulatives to hand, just to find some things that you can start to use. As teachers, we need to select the best manipulatives that we have available to us to make the learning visible. And we need to know what children will see when they start to use those manipulatives, so we can be prepared for questions and we can ask questions as children are using those. This picture here is a colleague and I working with some teachers in China. So their focus was to instill a sense of enjoyment in mathematics through the use of manipulatives. I'm going to show you a little video now, hopefully it'll work. And this is just about familiarity with Numicon. I thought it was quite useful to share this with you, so hopefully, fingers crossed, this is going to work. Let me make sure I have the sound on. So what you might have noticed is that Numicon is really brightly coloured, and that there are 2 categories of shapes, if you like. So we've got the regular shapes, and we also have the ones that are irregular, that have the little hat or a chimney sticking up an extra piece on the top. And you might have found some ways to order and sort them. I'm going to just show you quickly the staircase, which is the structured way of ordering the Numicon shapes. So we're going to just order them in size. If you see, I've got the chimneys, hats, sticky up bit on the right hand side, and I've just placed them in order of size, and there you see we have the Numicon staircase. You might have done, if you've done this and aren't familiar with Numicon, you might have organised the 2 upright, and whilst it's not incorrect, in this particular arrangement, it does lie down on its side for a variety of reasons. One, because there is a pattern. It goes 4 across and then 1 up, so it rises up on each of the odd numbers. And also that every even number has a base of 2, as do the odd ones, but they've got the sticky up chimney bits on the top. And if we had 2 in this arrangement, it looks like an odd number because it has the single 1 without a partner sticking up on the top. So this is the staircase arrangement. And when you've done that, you may well have seen that we can see odd and even pattern. So if I just raise the even numbers, we can see we have an odd, even, odd, even, odd, even pattern. And also here we can see the colour groups. So we can see 2, 4, 6, 8 and 10 as the even numbers. And we can also see we have 1, 3, 5, 7 and 9 as the odd numbers. And if we stack them up, we can beautifully see the colour groupings within Numicon. So the even numbers are all cool colours, shades of blue and green, and the odd numbers are all warm colours, which shows the relationships between odd and even. It's nice to see. And then the last thing I wanted to show you, if we just pop the staircase back out again, as you can see, we're doing odd and even alternately. 5, 6, 7, 8, 9, 10. What I wanted to show you was what we call the 10 sandwich as well. So you may well have noticed that we can really nicely pick out the number bonds of 10 here. But I'm going to show you how to do that if we use the 10 as a base. So you can see I've just picked up the 1 and the 9. And as you can see, if we match the shapes from either end to build the number bonds of 10, we can see that each time we remove 2 shapes, that the bond that's left is the smallest and the largest shapes available. And this is an interesting discussion, isn't it? That the 5 needs a partner. That's the only double that we have within the set of 1 to 10. Hope that was useful. That quick video, I hope it was useful for you. I'm going to go hopefully back to my PowerPoint. And it is back in the same place, which is brilliant. So now on to assessment for learning. And there are a few things I wanted to highlight here. The first is that there are 3 key elements of assessment for learning. They are assess, diagnose and remediate. So what this means is that during the lesson, teachers are continually watching and listening, and that we are picking up errors or misconceptions or a child that might be struggling. So we're going through the diagnosing bit. What's the problem here? What do we need to help the child understand? And then we step in and do some teaching or some support or ask some questions to deal with the issue. These key elements are cyclical in a lesson. We don't assess, diagnose and then stop. We are continually following those cycles within a lesson, and teachers do that so brilliantly well. And also we repeat that across a school year. So we are supporting our children in moving forward in their learning and making sure that we have the right amount of challenge and support available in the classroom. So after addressing an error or a misconception, we then ask a question to check the learning. So we're assessing again to determine if a child has understood the concept or the thing they were stuck with. So assessment for learning embeds the learning process throughout the teaching and learning cycle, if you like, and constantly adjusts instructional strategy. So teachers do this incidentally throughout a lesson. Assessment for learning is not a test. That's summative assessment. It summarises what a child knows. But these observations and conversations during a lesson really highlight what needs to happen next. So it allows us as a teacher to think about the next steps for that child or that group and what we need to do in the next lesson as well. So I want to just ask you a question. I wanted you just to think about for a minute. How do we as teachers, so you in your classroom, how do you identify errors and misconceptions in everyday maths lessons in particular? So I'm going to show you what I have seen teachers doing and also what I do myself when I'm in the classroom. So this is the key elements for me. So as a teacher, when we're thinking about the next bit of maths that we're teaching, we plan for common errors and misconceptions. So we start to think about what the children might find difficult or where the common misconceptions pop up, and we plan them in. So we plan to address them during the lesson. We are watching out for them. You might even give a question that highlights common errors and misconceptions, or you might start with a statement from a child, an imaginary child, who has one of these misconceptions, so we can unpick it and support that imaginary child in dealing with the problem. We also pre-teach to find the starting point. So we've probably all of us done in our time started a lesson and we realised quite quickly that the children aren't with us. We've pitched it too high, or it's too low and they're not engaging. So just to start the lesson before, so we kind of talk about the next bit of learning and ask some key questions just to find the starting point. What is it that my children know about fractions? Where do I need to start in my lesson tomorrow or next week? Track errors in the moment. This is really important. So we are watching through our assessment for learning where errors might crop up. We track them, we spot them, we deal with them there and then. We don't allow the child to keep that misconception for the lesson or for the duration of that topic, that we pick them up quickly. And to do that, we need to be really systematic and observant in checking responses. So for me, this depends how your room is organised, but if you have your room in rows, then you might want to check. So you might want to walk around and check row by row. Or if you use boards that children write on, ask them to hold them up row by row or table by table. So you can do a really quick visual check of a child's understanding of what you've just asked them. So ask a question, they write or jot their response down, you check those row by row, table by table. Instant feedback and marking is crucial for assessment for learning. It's difficult for teachers to do, but if we can focus in even on a small group or those that you think might have some problems in this lesson, then we can start to think about noting the errors, modelling again what it is you want them to do, or stepping in with questions and then a bit more teaching, so we are not letting the child's misconception or error continue for the lesson. And this process allows us to plan for appropriate learning opportunities, that allows us to pitch our challenge correctly for the lesson and the children involved. Again, I'm going to try and show you a little video. This is a teacher in England who is talking about the benefits of teaching and learning. So she is able to think about and plan for these types of questions. Fingers crossed again that this works.
The children are going to work in groups on big sheets of paper because I want to generate a lot of discussion, a lot of deeper thinking. The children are all very competent in the column method for addition. We're looking at Bridging 100, which is below them, but I'm really looking for my formative assessment to see which children, as I say, follow a procedural method or which children actually understand addition. So I've set up on the tables, the children are going to have baseboards. They're going to have all the Numicon shapes. The context is a shop. We're going to look at doing a stock check and look at boxes and trying to find a way of bridging 100 to make addition easier for us. Firstly, I will demonstrate an example so they can all see how I've used Numicon to assist me in doing the addition. Then I will set them a similar example for them to work through as I will walk around the room, make sure to iron out any errors and misconceptions. We'll come back together as a class, go through the worked example together, and then I'll set them off. I've got some children who I'll expect to go well beyond 100 almost immediately, and some children I know will need quite a bit more support just to deepen and cement that knowledge first before I expect to move on. Okay, in my toy shop, we've got lots of boxes in our storeroom, and they can hold 100 things in each box. Now, unfortunately for me, I haven't had very good staff before. And instead of using one box up, they've used some out of one box and then some out of another box. So I don't know how many I have got left. So do you think you can help me with that?
Yeah.
Right. In my first box, I've come and looked for my action figures, like my action men and my Star Wars figures and all things like that. In one box, I've got 80, and in the other box, I've got 44.
Numicon emphasises 3 key aspects of doing mathematics: communicating mathematically, exploring relationships, and generalising. Communicating mathematically includes, but is not simply another way of saying, talking. Children should be encouraged to engage in dialogue with their classmates and with teachers and teaching assistants as they explain their thinking. All partners in a dialogue will be actively involved. Having these exchanges will encourage children to discuss different suggestions and allow them to express their thoughts. Communicating mathematically also involves children being active. This is actually doing the mathematics, both the activity and the thinking and the illustrating, as opposed to being told how to do it. Children are encouraged to explore relationships within a wide range of contexts as they communicate, so that they learn not only how to do mathematics, but when the mathematics they are learning is useful. Fully understanding the relationships in a situation makes that situation predictable and allows us to work out or manage what is needed to control the situation. It is generalising that allows us to make whole ranges of new situations predictable. Noticing a pattern in a relationship opens up our generalising about an infinite number of other similar situations. Each lesson and activity should reflect an opportunity for children to generalise. For example, a number sentence is a generalisation. By making that sentence, you are showing that you understand that pattern will always be followed, no matter what the subject of the sentence is. 5 and 4 will always equal 9, be it 5 pens and 4 pens, 5 tens and 4 tens, or 5 millions and 4 millions.
So the lesson's just finished, and I felt it was successful in showing me quite a few different things, lots of discussion, which I was really, really pleased with, because that's what I was aiming to see. I also felt it showed me that some of them need further cementing with their written methods. One was trying to do the column method for addition, and she did something and she forgot to carry her 10 over, and so it made her stop and think, and she went, oh no, that's wrong, I'll have to do this instead. It was a real team effort, I felt.
Hopefully that's given you a little overview of the importance of manipulatives and that ability manipulatives give teachers to perform their assessment for learning in action. So last 2 to think about. The 4th one is reasoning and problem solving. And I think this is so important for children when we're looking at inspiring that love of mathematics, for them to understand that maths is something to get involved in and to enjoy. So reasoning is the process of applying logical thinking to situations and also selecting the right strategy to find the answer. And problem solving is finding a way to apply what we already know and our skills to answer a problem. It isn't just about word problems, it also includes things like puzzles and investigations, and one of my favourite things, which is exploring statements. So is a statement all times or never true? So for example, I could say, when I add 2 numbers together, the answer always gets bigger. So does that always happen? Does it happen sometimes, or does it happen never? And I'm thinking particularly here of adding of negative numbers and whether that means that we always get the answer that's bigger. So reasoning, what are the key ideas? The key ideas for me is that children need to be taught how to record their thinking and reasoning in maths as they are describing and replicating and pattern building, exploring properties and relationships. Sometimes the recording, they're not quite sure what to jot down or how to do that. So as a teacher, it's our job to show them what recording might look like. And also their skills. Are they, what are they using? Objects, pictures, numbers or shapes? And also what is definitely happening and what might be. So what can they conjecture and what are they trying to find out? These skills help children to clarify what's the same and different, to use their knowledge from other learning and collect evidence when testing statements or predicting hypotheses. So for me, these are definitely key to reasoning. So deduce, create, hypothesize, apply, predict, and explore. Those are my key words around reasoning. I wanted to also touch quickly on the inquiry maths model. It may be something that you're familiar with, but it's a particular way of teaching, and it involves a statement or a diagram called a prompt being given to the children, and then they use all their skills, their knowledge, their questioning, they conjecture and generalize, and they're listening to the teacher's explanations, that explicit teaching, and then they get on with the inquiry, and they kind of find out and the things that they are there to be noticed and to talk about. It does support student engagement. It does encourage thinking, reasoning, and problem solving in lots of different situations. So very engaging for children, and a lot of children enjoy maths inquiry. Here's a little slide which you will have later on your handout, so you can come back to, but this is just 10 reasons to use inquiry-based learning. I'm not going to read them out to you, but this is about deepening understanding. It's about you know, perseverance. It's around ownership of their own learning, increasing motivation, those types of things, and that inquiry-based learning supports that. So why promote it? I'm not going to read this out to you either, but this is some research from Teresina Nunes, who is very well known in the UK. But what she said was, her conclusion was that children's reasoning, more than their knowledge of arithmetic, is actually a predictor for their later achievements in life, which I thought was really important. It's their reasoning skills that predict their ability later. We're going to have a little think about something here, which is an activity that I often give to younger children, so probably around 6 or 7, for example. And it's definitely an activity where they need to think and reason, but also it's how they record here. How are they going to record what they're finding? So this is an interesting one. So Chico's cards are all different. So each card has got a different number on. He has numbers 1 to 8 only on the cards. So Chico picks 4 cards, they add up to 20. What could they be? So what could those 4 cards be that add up to 20? And here's a little helping hand for those children. There are 7 different possibilities. Can you find them all? This is really encouraging them to be logical in their thinking, to work systematically. So to start with the biggest number, which is 8, and find the possible combinations with 8. You can see how this would be good with manipulatives, so things like Numicon or Cuisenaire rods, but also how are they going to record them? So here's a quick screenshot here of a way of recording, and also the answers on the right-hand side in case you want to have a go at this yourself. And I really like Numicon for this because it allows us to see that bank of 8 at the beginning. If we start with 8, what are the possible combinations of the other numbers we have left? So 7, 6, 5, 4, 3, 2, 1 that can make 20. So I've made a template of 20 at the top, you'll see. Just quite a nice little activity if you wanted to try that one out. And the last section I wanted to look at with you was contextualizing learning. For me as a child, this was missing a lot from my teaching. I found maths quite difficult and came back to it later in life. And when I came back to that at university, my lecturer gave us lots of contextual situations in which to explore and find out about mathematics in. And that made much more sense to me. So I suppose what I wanted to say here was that maths can feel very abstract, and that can mean that it's a difficult subject for children. If they find it difficult, they often don't enjoy it. If they don't enjoy it, then we don't inspire that love of maths. So this is an important area for me. Reigniting previous learning, so remembering what we've done before that's similar helps us to put the maths in context that we're learning now. It also makes us link concepts together more clearly. So this is a little bit like our learning we did here. Highlight where this maths learning can be used in real life, really, really important. A lot of the maths that we do is very much linked to real life situations. So let's teach children where they might need a particular piece of learning or how a skill they're developing will help them in later life. So where is it relevant? So for example, fluency in number skills are really we're faced with money situations. So working out how much change we're waiting for on the spot really quickly. Rounding and estimating are really important skills when we are looking at shopping and have we got enough to pay for something. I don't know if you eat out with friends, maybe not at the moment, but if we are looking at, 4 friends going out for dinner and the bill arrives and we all want to pay our way. So how do we divide the bill between 4 people? And the last example here is something that I love doing. So cooking, for example. So if we have a recipe for 2 people, how do I make enough food for 6 people? So scaling up that recipe is really important. And maths is everywhere. This is so crucial. So maths is in sport and performance. If our children are sporty, then, it's important to show them that maths is important to that. Sport and performance is quite technical in terms of maths. In gaming and digital media, construction, engineering, in medical research, it's central to transport and manufacturing, really important in the arts and creative pursuits. It's obviously completely embedded in sciences. It's around us everywhere in our weather and seasons, in space exploration, the universe. So if children are going to put the effort in, if we're going to encourage them and inspire them to put the effort in, they need to know it's going to be worth it. And so here's an example of putting maths into context. It's a page from one of my Numicon books that I have here at home. So like you, perhaps I'm actually working at home quite a lot. So this is an activity where a teacher has already taught about percent. They've done lots of practical activities, and now they're looking at applying and recording what they've learnt. And I just thought it was a really nice example of a situation where percent might be important. So this little boy is called Ben, and he's talking about his great grandma who was 100 years old today. So 100 years is called the century. So we have some practice questions around how we can use percentage here. So if Ben is 10, grandmother is 100, what percentage of her age is he? Then you've got things like doubling ages, what percentage would that be? And then Ben's dad is 50, it's a really important, 50% halfway. And then you'll see some going deeper questions, some more investigative questions at the bottom for children to get their teeth into when they've kind of worked through those. So for me, just before we finish, a quick review of the 5 tips. So we've looked at approaches. That's the approaches to teaching maths to help us inspire and engage children. The use of manipulatives, really central to understanding and enjoying mathematics and help us with our approaches and also our assessment for learning, which is the next one. So as teachers, assessing in the moment, stepping in to teach and ask questions, understanding the next steps or where common errors and misconceptions happen, very, very important. Promoting reasoning and problem solving and all the rich maths tasks that enables us to provide for children really inspires them and get them involved in their learning, so they hopefully will enjoy that type of activity. And the last but not least, to contextualize what we're doing. Where might they use the maths they're learning? How important is this for wider life, so that children can see the relevance of maths and the importance of it and also the beauty of it. So really important to make maths as real as possible. And finally, thank you so much for joining my session, and I hope to see some of you on the Q&A. Thank you, bye.